What's up, guys, and welcome to this tutorial on question 3 of the 2016 final exam. Final exam. This question is on kinematics and is worth 21 marks. Okay, cool stuff. So 5 children, A, B, C, and D and E, are playing in the street outside their homes. The street runs in an east-west direction. The positions of the children are plotted on the position time graph. Define east as positive. Okay, so first things first, east. Okay, so first let's understand what's happening. Okay, so these children are running. We've been given the position time graph. Okay, so with the position time graph, I can say that the gradient is equal to the velocity. Okay, and I also know that east is positive. So anything in the positive part is going to be east, and anything that's going into the negative part is going to be west. Okay. Yeah, cool stuff. Okay, so let's get started. Use the graph to answer the questions that follow. Use only the correct letters in your answer. Okay, which of the children are running west? Okay, so to be running west, we are going to be looking at children that are getting close to or moving towards west, right? So they have to be running downwards basically. Okay, so that's not A. A is running eastwards. B is also running more eastwards. C is also running eastwards. D, okay, so D is running from a position, let's say that's 5 meters east to a position that's less than 5 meters east. So he is running, or that child is running west. So this would be running west, and with the same logic, E is also running westwards. So I would say that is D and E. Okay, cool stuff. Which of the children, okay, so the next question, which of the children are running at a constant velocity? Okay, so we already mentioned that the gradient is equal to our velocity. So if we have a straight line gradient, or a constant gradient, then we will have a constant velocity. Okay, so A fits the profile. B, the gradient is changing, so that can't be right. C, we also have a changing gradient, so that can't be right. D and E have constants, so it's going to be A, D, and E. Okay, and it's no coincidence that the number of marks is equal to the number of people. Okay, so we get 2 marks there and 3 marks there. Okay, so which of the children are slowing down? Okay, so A, okay, so we take out A. We already said that A, D, and E are running at a constant velocity. I mean at a at a constant velocity. So what we're left with is B and C. Okay, so if we look at B, his position, as we get higher, his gradient is increasing. So he's getting faster, or this person is grading faster. So it can't be B. And for C, okay, so the gradient is slowing down, so his change in position or change in displacement is getting less over time. So that means that C is slowing down. So the answer is C. Okay, which of the children has the highest average speed? Okay, so we're looking at the gradient again. The higher the gradient, okay, so E has got the highest gradient, so it must be E. When you compare E to D to B to A to C, E has got the greatest gradient, and therefore, yeah. Okay, so describe what happens at the point labeled P. Okay, so at the point labeled P, what can we say? Okay, so if we look at this point, okay, so there's our time T, and this is some position P. So at that point, B and C are at the same position. Okay, so we can say that child B and C are at the same position at point P. Okay, so they're the same place basically. Okay, yeah. Okay, question 3.2. Definition, here we go. Define distance. Okay, I like to do a definition if I see it, because then I just get it out the way. Okay, so define distance. Distance is the length of the path traveled. Okay, and we get 2 marks for that. Okay, now let's read the question. A puppy is running at a constant speed of 2 meters per second. So speed equals 2 meters per second towards a mud puddle that is a distance of 6 meters away. So the distance equals 6 meters. That's 5, 6 meters. Okay, so how long does it take the puppy to get to the puddle? Okay, so we can use question 3.2.2. we can use the equation, just a basic equation that we use in maths, that speed equals distance over time. Because we know there's no acceleration, so we can say the speed was 2, the distance is 6, so the time is the unknown. There's only one unknown here, which is time, so we can solve for t, and t equals 3 seconds. Okay, and we get 3 marks, a little bit generous for such an easy question. Okay, but anyway, Lauren is 10 meters behind the puppy and is running at a constant speed of 4 meters, chasing the puppy. How far does Lauren run in the time it takes the puppy to get to the puddle? Okay, again, 3.2.3, we can use the same speed equals distance over time. Okay, so the speed is, Lauren's speed is 4. Okay, yeah, 4. Then the distance is what we're looking for. So how far, we're looking for the distance, and the time that it takes the puppy to reach the puddle was what we calculated before, so that's 3. So the distance is the only unknown in this equation, so we can solve for it. So the distance is equal to 12 meters. Okay, so question 3.2.4, how far is Lauren from the mud puddle when the puppy reaches the mud puddle? Okay, so let's understand what's happening here. So we have a puppy that, okay, so here's the mud. The puppy is 6 meters away from the mud, and Lauren is 10 meters away from the mud. Okay, so she is a total of 16 meters away. Then in the time that the puppy gets to the mud, she runs 12 meters. So she runs somewhere here. Okay, so how are we going to get that distance? That is simple. So it's 3.2.4. We can say that Lauren is 16 meters minus the 12 meters. So let's say distance equals 16 minus 12. So the distance is 4 meters. Okay, so she is 4 meters away from the mud puddle. Okay, does that make sense? She was 16 meters, then she runs 12 meters, and so she is 4 meters away. Okay, so Lauren doesn't want the puppy to get dirty. Her initial speed is 4 meters per second, and she accelerates uniformly to ensure she catches the puppy at the instant just before it reaches the mud puddle. Calculate the magnitude of Lauren's acceleration. Okay, so basically we want to make sure that Lauren gets to the puppy before the puppy gets to the mud. Okay, so the puppy gets to the mud. Okay, so this is a UVATS question, hey, because we say we have constant acceleration or uniform acceleration. So UVATS. Okay, so we know U is 4 meters per second, the final velocity is unknown, the acceleration is unknown, the time is known. Okay, so we want her to be able to run that 16 meters in 3 seconds, because that's when the puppy reaches the mud, and we also know that she needs to run a total of 16 meters. Okay, now what equation can we use? We can use the equation S equals, that looks like a 5, S equals ut plus a half at squared. Okay, okay, so everything is happening in that one direction, so everything is positive. Yeah, I'm happy with that. So S is 16 equals U, which is 4, times T, which is 3, plus a half, times the acceleration, which is unknown, times T, which is 3 squared. Okay, so let's see, we're left with only the acceleration being unknown. So if we solve for A, we get 0.89 meters per second squared. And yeah, That's the final answer because it asks for the magnitude. We don't care about the direction. But if we did care about the direction, it would be towards the puddle or something like that. Yeah. Okay, so we get 21 marks for that. Nice, easy question, nothing too difficult, not too much thinking. Yeah, cool stuff, guys. I hope you guys found it useful, and thanks for watching.